Hello, I'm Selin and welcome back to our channel. In this video, we are going to discuss the graph-based method in facility layout planning. But first, we need to ask this question: why do we need a layout algorithm? We are designing a new production facility. We have several departments that need to be arranged on a floor plan. Some departments interact heavily with each other, some don't. Materials flow between them. Workers move back and forth, products pass through them in a sequence. Departments that interact a lot should be placed close together, right? Naturally. But how do we decide who goes next to whom systematically? We need a system for this. We have some challenges, we have some data to examine, and we have an objective. So multiple departments cause multiple possible arrangements, and we have this criteria conflict. What is good for one pair may be bad for another. And the manual trial and error doesn't scale at all. We have generally, most of the time, always have a relationship chart, which captures how important it is for each pair of departments to be adjacent. These values are expert assigned scores, qualitative judgment turned into numbers, and higher score means stronger need for proximity. And what we want a layout that maximizes the total agency score, and we want departments with high relationship scores to share a common boundary, and we want a systematic reproducible procedure. Where does the graph-based method fit? A construction algorithm builds a layout from scratch. No initial layout is needed. Graph-based method is a construction algorithm that uses only the relationship charts as input. Here's some other methods you can see in this table if they are construction algorithms or improvement algorithms clearly. So what are we maximizing? We are trying to maximize the sum of relationship scores for all adjacent pairs. We have some variables here. M is number of departments, Fij, the relationship score between departments I and J from the relationship chart. And we are going to solve a question, you will understand it better. And Xij equals to 1 if departments I and J are adjacent. In the layout, 0 otherwise. Two departments are adjacent if they share a common boundary in the block layouts. This is something that we need to keep in mind. Corner touching does not count. They must share an edge. Here we explain what relationship chart is and some other concepts. Relationship chart is a systematic matrix where entry Ij is the closestness score between departments I and J. Only the upper triangle is filled. The metric is symmetric. And each department is represented by a node. Each pair of departments is a potential arc, and the number on each arc is the relationship score Fij. Two nodes connected by an arc in the final graph, those departments will be adjacent. A graph is planar if it can be drawn on a flat surface with no arcs crossing. However, relationship diagrams are often non-planar. This is one of the method's no limitations. We have some steps to apply. The first step is we select a pair of departments with the highest relationship score. These two enter the graph first. Then we select a third department. We will choose the one with the highest total score relative to those already in the graph. And we are going to select the fourth department and its face. And we are going to continue until all departments are placed. And as the last step, we are going to convert the graph to a block layout, which is translating agencies into a rectangular floor plan. I want to mention some of the limitations of the method. We don't consider distances. The agency score only cares whether two departments share a boundary or not. Department size are ignored. We assume that all departments are equal in size. And non-planarity problem. Relationship diagrams, as we mentioned earlier, are usually non-planar. Arcs cross when drawn on a paper. A non-planar graph cannot be directly converted to a block layout without losing some adjacencies. You will see it in the example that we are going to solve. And it has high sensitivities to score values. So small changes in the relationship chart can produce completely different layouts. The method is only as good as the expert who fills in the scores. We have a little case study here. A manufacturing facility wants to determine the block layout for 5 departments, A, B, C, D, and A, using the graph-based method. The objective is to maximize the agency score. We are going to construct the final agency graph step by step and calculate the maximum agency score. So here's the relationship diagram that I drew. I did this off camera because I'm the slowest writer on the planet. We would lose so much time. So this is our relationship chart. So we can see that A and B have the score of 15, and then A and C have the score of 5, and A and D have the score of 10, and A and E have the score of 2, and B and C have the score of 25, B and D have the score of 8, B and E have the score of 12, and C and D have the score of 30, and C and E have the score of 4, and D and E have the score of 18. First, choose a department pair with the largest weight, which is C and D here. So we draw it here, here's C, here's D, and their weight, which is 30. Second, we are going to select the third department to enter. It's selected based on the sum of the weights with respect to department C and D. So we have C and D here and remaining departments A, B, and E. So the score between A and C is 5, and the score between A and D is 10. Their sum is 15, sorry. The score, I always want to say distance, but these are not distances. The score between B and C is 25, and the score between B and D is 8, and their sum is 33. The score between E and C is 4, and the score between E and D is 18. When we sum them up, we have 22. So we are going to select the highest number, which is 33. So we are going to place B next. So we have this here, and then we are going to place B here. So we have a triangle. So B and C are connected, B and D are connected, and C and D were already connected. Next step, we are going to determine the fourth department. We have one face in the diagram now. So this is the face here. This is our face. The sum of the weights of the remaining A and E, sorry, will be taken into consideration again. So now we have 3 departments to consider. The score between A and C is 5. The score between A and D is 10. A and B is 15. E and C is 4. E and D is 18. E and B is 12. Again, we have all of these right here. So again, we sum them up and we will choose the highest number again, which is 34, which means that we will place a E between them, like in the face of the triangle, sorry. So E is here, and now E is connected to C, and E is connected to D, and it's connected to B, right? So let's go to the next step, 4th step. Where will the last department go? And we now have 4 faces, and we want to determine where will A go. So I want to show you the faces. So this is a face between C, E, and D. This is a face C, E, and B right here. There's a face E, D, and B right here. And the 4th face is the outer face, I guess, right here, all the colored sections. Now, we will take faces into consideration, and we have A left, and we are going to compare the scores, and we are going to sum them up. The same thing, but we are going to do it for all faces. So face B, C, and D, we have A's scores between those departments, and A and B is 15, A and C is 5, A and D is 10, and their sum is 30. Ignore this part for now. Face B, C, and here, right here, this face. So are we going to place A here? Let's see. So A and B is 15, A and C is 5, A and E is 2, their sum is 22. Let's consider the face B, D, and E right here, the purple face. And so A and B is 15, and D is 10, and E is 2, so their sum is 27. So we have last face left, which is C, D, and E right here, the green section right here. A and C is 5, A and D is 10, and E is 2, their sum is 17. So we choose the maximum one again, which is 30, which is this right here, this face, B, C, and D. We are going to place it here. I'm going to show you how I placed it, but let's consider other faces again, just to, summarize it all. So face B, C, and E right here, the total score is 22, and we already have the maximum, so we are not going to place it right here, or here, or here. It's going to be here. So it's, to my best ability, it's going to look like this. Again, this is, yeah, you can imagine it's located in the center, but, in to the drawing, it's not really easy to see and understand, but this is how it will look once we place all the departments. And remember the last step, we are going to put them in a block plan right? So, and B are here, E is here, D is here, C is here. This place is empty. We can quote aisle. So non-adjacent pairs A and C, right here, their score is 5. A and D, their score is 10. And E, their score is 2. B and D, 8. C and E, 4. Let's go back to limitations of the method. So non-planarity problem. Relationship diagrams are usually non-planar. Arcs crossband, they are drawn on a paper. And a non-linear graph cannot be directly converted to a block layout without losing some agencies. So you see it here. It's really hard, but it's a really easy heuristic to apply. So I guess it's acceptable. But here it is our block layout. Thank you so much for listening, and hopefully we will see you in our next videos.